Hey everybody, welcome back. Today we're going to be looking at using the idea of a grappling hook inside of Unreal to pull ourselves to a target, and also the ability to be able to pull things to us. So let's get into it. First thing that we're going to want to do is set up a separate collision channel that will allow us to interact with the objects that we have targeted specifically. So for this, I'm going to come down to my engine, and we're going to go down to collision, and under collision, I'm just going to add a new object channel. So over here, just click new object channel, name it, and set its default response to block. Now that you have that, you can identify objects in the world as tetherable or not tetherable, and that'll be really useful for the way that we're going to be tracking things later. I also needed to come up with a way to fire off this thing, so I created an alternate input, and in my IMC, I just attached that to the right mouse button. I also wanted to create an abstract class that represented the idea of something that could be tethered. And so I have two states that this thing can be in. It can be anchored or not anchored. And then I have a static mesh because anything that we're going to anchor to or bring to us is going to have a static mesh to represent it. And so I made a static mesh here as part of the default. And then when I roll on down to the collision, I just changed the collision to custom. And that allows me to change the object type to the tetherable channel that we just created inside of the project settings. So when this is tetherable, that means anything that's looking for tetherable is going to try and block with this object, and this will block with everything else as well. This abstract class is set here inside of the class settings. Looking forward to the implementation of that abstract class, we've created a child actor, and the way to do that is if you have a BPA class, or any class really, you could just right click on it and go to create child blueprint class. If you created a class and you forgot to make it a child of something else, you can of course always go up to your class settings and then change the parent class to whatever you want. So if I wanted this to derive from actor, I could do that. If there's things in here that are relying on some functions or variables that came from before, then that could become problematic. So for this static mesh, I assigned the arcade editor sphere. I just got that from the engine utilities and applied this asset material to it. And I didn't need to do anything with the collision because that was inherited from its parent. So this by default is going to receive that anchored true, and that works out for us. There's nothing that needs to happen in the event graph, and now we have an anchor we can place in the world that players can tether to. We also wanted to have the opportunity to have a tetherable pickup, so something that can be brought to the player. And so for this one, it's also, you can see up here, child of the BPA tetherable class. I have it set up for overlapping, and so it is a tetherable object, but it will move through things, and the player can move through it. So in order to account for that, I gave it a static mesh that has some blocking components to it. And then I also have the sphere, which is a sphere collision that allows me to fire off when that gets overlapped by the player character, whatever pickup ability we want to have. Ideally, we're going to create a function and then extend this function for any children of the pickup type. And then we're going to destroy the actor after it's been picked up. If you have things that you don't want to destroy and just bring to the player, like platforms or enemies or things like that, you can just ignore this. You could even make this as a component if you wanted. So in addition to the tether targets, the things that I'm going to be shooting the tether at, I need to have the tether hook, the thing that's going to actually fire from the player and connect with the objects inside the world. So for this, I have a static mesh that I made the scene root for the blueprint actor. This is very much how we'd set up a projectile, and we did set up projectile movement on this. I zeroed out the gravity and I gave it a pretty decent speed. And then I added this thing called a cable actor. And so you can find that by going up to the top and typing in cable. So the cable actor by default has a number of segments along with it that'll droop to give you kind of the idea of a real rope type actor. I just reduced that down because we don't really need it to droop. If you want to have something that has more slack in it, you can of course increase the number of segments that you have. I have the hook here is the name of the root piece, and so I have the cable attached to the hook by component name. So when I expand out this attached to, I just typed in the name exactly as it appears here inside of the components list, and then that will attach this so that when we fire it, the cable will go with the projectile. So we would need to tether this other end to something, and we're going to do that by attaching that to the player. So with this, a number of settings you can do with the cable actors. They're really fun. If you haven't played with them, check them out. They work well for the purposes of what we're doing here. Inside of this tether hook, I have a few different things. I have on event begin play. I'm going to get the reference to the player, and I'm going to save that as a variable. And then I'm going to reference this muzzle actor inside of the player character. And just to take a glance at that, in a previous tutorial, we talked about projectiles, and this is just a placeholder muzzle. So this is a cube with absolutely no collision on it, and I just named it muzzle. So this is going to pivot with the character. As I look down, it looks down. As I look up, it looks up. So it's just the transform of that thing is attached to the orientation of the player. So the tether hook is going to get the muzzle, and it's going to determine that is going to be the parent for this component. So the cable is going to, we're going to use this attach component to component, which is going to say find a component of this, and in another actor, find a component and use that as the parent for this component. So it's going to attach as that one thing moves, the other thing will move as well. So the tether hook will be its own actor in the world, but the cable is going to attach itself to the muzzle. And these relative rules, these are important if you're going to be translating things over time. We're not as worried about that right now, but the idea that you can control these things and have them be relative or absolute when you tether them to something else can be pretty useful. I also have that the hook has a component hit. So if I go over to the hook, you can see the different events that we have here. So on component hit, I'm going to check to see if it is a type tetherable. So the hook is going to know whether or not it's hit the right type of thing. If it is, then we're going to get that reference to the player, and we're going to perform our tether action, whatever you set that up to be, whatever you name that. This is our created function that's going to be inside of the player. We'll get to that in just a second. And then if it ends up hitting something that isn't a tetherable object, then we're going to destroy the actor, and we're going to call a function from that character that's going to say stop tether, which does a little bit of cleanup for us. So with that in place, we can go ahead and head over to the player character now. Nothing was needed to be added to the player character. If you followed along with the firing projectiles in first person, it's basically the same construction. What we're going to look at is this big box over here. There's a lot of things going on, but mostly it's just some math. So I have my input action for the alternate fire here, and we're going to just check to see if we are tethering, because we don't want the player to be spamming tether. So if they are tethering, then we're not going to do anything. If we are not tethering, then we can do a sphere trace for objects. When you go to do a trace, there are a number of options. There's multi traces and single traces. Make sure you don't do a multi-trace. A multi-trace is going to give you an array, and if you just do a regular sphere trace, that will give you just the single objects. There's also traces by channel, and so there's sphere trace, box trace, all those trace by channels as well. But we're just going to use for objects because we created an object channel inside of our collision system for the engine. So when this fires off, it's going to see if we are tethering. If we're not tethering, then we're going to fire off this sphere trace, and I can draw the debug here so you can see what that looks like. So that's firing off this set here, and whenever I get a connection, it's going to make it green. You'll see that little red dot up there. The little red dot means that that's the exact point that it hit the thing. So this sphere trace is just going to start off by getting the muzzle location. So we're starting from where the thing is going to be fired from. If you have a model for your gun, then this is going to be whatever socket is attached to the muzzle of that. We're going to get the world location of that, and that'll be the start of our trace. So for a line trace, you need a start and an end. For the shape traces, you need a little bit more than that. The sphere trace is the next simplest one, where it only needs a radius. So in order to determine how far out we're going to send this trace, we're going to determine where the end is going to be. I'm going to get that location of the muzzle, and I'm going to add to it the control rotation, which is the direction the player is looking, times the tether range, which is a variable that we've set up down here. It's just set to however far you want the player to be able to reach with the tether. So if you have a game where the player can upgrade their stats, maybe this is something that the player will be able to reference later as their skills grow. With the control rotation and the tether range, we're going to get basically a vector out, and we're going to add that on top of our muzzle. So this will tell us where the end of that line is going to be. A common mistake that people run into is they'll have a radius for their sphere trace, but they will set it to 0. If it is a 0 radius on a sphere trace, it will not work. You have to have at least some thickness and radius for this to be able to process the information of collisions. So make sure that you do set that value up. Here for the sphere trace, we also want to create a variable here. For this, I just did right click and promote to variable. And this is going to give us an array of object types that match what this trace is looking for. When I select that variable, you'll see over here that I've selected tetherable. So you just have to click plus to add a new type. And then from the dropdown, add the type of object that you'd like to interact with. And for us, that's tetherables. This means it's going to send out a sphere, and it's only going to register a proper hit, that green part of the trace, whenever it was that it overlaps or connects with a tetherable object. From the trace, you almost always want to run to a break hit result. The hit result can be expanded on the node, but it gets a little sloppy because there are a number of items that could be interpreted from it. So you just want to grab the ones that you need and then collapse that back down. So with the hit result out, we're going to do a branch, and we're going to check that we had a blocking hit. This is different. This isn't just if there was a hit, but a blocking hit specifically. So if we had a blocking hit, and that's true, we're going to check the other actor to see if it's a BPA tetherable, means any type of tetherable object. And if it is, we're going to preserve that in our tether target. So I'm going to set a variable that we have down here, tether target, so that other parts of our scripts can know about which target we're looking at. Then we're going to find the look at rotation to fire this thing. Because if you recall, we have our hook, which is just going to fire off in a straight line. It needs to know which direction that straight line is. We got the information for this trace, but the trace may not have been exactly right to the object that we're looking at. One of the reasons that we're using a trace sphere is maybe we want the player to have a little bit of grace with their aim. Maybe this is a little too precise for them, and you want to give a little bit of opportunity for them to miss. It's kind of like aim assist, and so it'll grab the nearest hit point for the collision. So if you want to be more generous, you can increase this radius, and then that will allow for the location of wherever this trace is going to produce a result on impact, that red dot that shows up on our collision, to tell us exactly where the tether should connect to the object, so it's not floating in space down our crosshairs. So we have the look at rotation is going to start with the trace start, and then it's going to end at the impact point. And so this is going to set a current look at value for us. This is a rotator that's going to help us maintain that orientation as we use the rest of the scripts down here for actually connecting the tether effect. And then if that all connects, or when that all connects, we're going to set up that tethering is now true. So since we are tethering, we can go ahead and fire our tether hook. So we're going to spawn the actor, and we're going to get the world transform of the muzzle, and we're going to pipe in the rotation from the set current look. So get world transform, all I did for this node is it originally came out like this, and I just went right click, split struct, and then I can wire that up here. I split struct on the spawn BP or spawn actor of class as well. I split that struct so I could intercept the rotation with a new value. Once I spawn that hook, then I'm going to reference current hook here. Depending on what you're doing with your error handling or what features you're trying to add to the game, you may want to do some additional references to this for things like sound, or if you're going to be dealing damage to enemies and things like that. I had this here for debug, but we don't need that right now. All right, so with this will fire off our hook, and our hook is actually going to take care of the actions. Remember, we had the collision here on component hit. If it is a tetherable, it will perform the tether action, and if it isn't, it will destroy the actor, which is the hook, and stop the tether action. So performing the tether action, we're just going to do a little basic physics. So we have the perform action is going to set the play rate on a timeline. The timeline is going to, depending on what we hit, if we hit an anchored point or a non-anchored point, is either going to launch the character towards the thing, or it's going to set the actor's location as closer to the player. So when that's finished, that will stop the tether. If the thing that we're modifying gets destroyed along the way, then we're going to stop the tether as well. So to look at stop tether real quick, it's basically going to have the current hook. Look at the current hook here. So when I do get, if I just want to make sure that the current hook does exist, I could run is valid here, or I could just convert this to a validated get, and it basically gets me the same thing: is valid, is not valid, and it's associated directly with that variable. So if it is valid, I have a hook. Then I can destroy that actor, stop the timeline, launch the character up 2 units, or however it is that you want to like pause the character whenever they detach from their grappling hook, and then set tethering to false because they're no longer, the hook doesn't exist and they're not moving with it. If it's not valid, then it's just going to stop, and then it'll launch the character. This is like an edge case handling for when the player is expecting to do something, but the tether has been unexpectedly destroyed or interrupted. So coming back to the event graph, this tether target, we're going to grab the anchored variable off of that. If you can recall, in the BPA tethered, we just had anchored true or false. And so if it's true, then we're going to launch the character with the velocity that is the tether speed, and we're going to send them in the current look at direction. So to get this node, I simply used a multiply. And for the multiply, you can set these to whatever you want. So here I can take rotator. Rotator's expecting a float. And then on the back end, I can switch this to vector, and I can get out the variables that I want. And once this is actually hooked up to a rotator, this will not change around on you. So if you're looking for this node specifically, you have to kind of put it in place and then attach the pieces to it. All right, so that is going to launch the player at the target. Then if it's not anchored, what we're going to do is we're going to set the actual location, and we're going to use the lerp vector. And so this tether target here is going to be what's moved. So the thing that we hit with our grappling hook is going to be moved specifically towards the player. The B for the lerp is the player location, because we're in the player script. And then the tether target's location is going to be what's moved closer and closer to the player. And so this is going to happen because our timeline is using a growing function that goes from 0 to 1. So it will eventually connect to the player as long as it goes through 1. You can change the rate that it goes through that. I have this slightly accelerating, starting off slow and coming up high. This is on a curve that I created separately, so you can see the outline of the curve here. So if I wanted to, I could choose from my curves that I've created for my project. You could play with that a little bit to see if you get a little better game feel. And all of this is being determined in time based off of a simple physics calculation. The speed that the timeline is going to play at, since it's only a one duration timeline, is going to be relative to the 1 over however long we want it to play it. So if I want it to play for 2 seconds, then 1 over 2 is half speed, so it will take 2 seconds to complete. 1 over 6 will take 6 seconds to complete, as it plays at 1/6 of the speed. So in order to get that speed in seconds, we have to use distance, our dirt formula, distance equals rate times time, or distance divided by rate equals time. So I have the distance, the player, and the tether target, and I'm going to get that distance, and I'm going to divide it by the rate, which is our tether speed. So this is how many units per second we'd want them to move on average. So 900 units tells us that no matter what the distance is going to be the outcome, because we're going to get the ratio of those things, and that will inform this 1 second split to tell us how long we need to play in order to get that constant rate. So this helps us to have a little bit more consistency in the way that the tether or the grappling hook is implemented. So once that's all called, the timeline will play, pulling one to the other. If I get to the object, it will stop tether, which will do the launch character to stop my momentum. And if I collect the object, that will invalidate the object, and so that will also stop tether. And in this way, we're kind of accounting for all scenarios that you would expect. Now, what you do with the tetherable pickups or whatever tetherable objects, tether anchor, tether pickup, tether movables, just make sure that you're implementing the correct collision type for the static mesh, and then that should allow this system to interact with those however you want. Now, you may want to adjust the speed based off of the type of objects that you have, and so this would be good to maybe have a enum of all the different types, and then you could change tether speed based off of the input before it gets to the timeline, and then whatever it's doing will operate at different speeds. If it's a light, medium, or heavy object, you can pull it to you at different rates, or depending on what size it is, you'll determine whether or not to pull it to you or send you to it. But hopefully this gives you an idea of how the system can work, and so you can see it in action, pulling these towards us, and then I can also swing, and it stops my momentum there. If you want to maintain the momentum, you can always capture that and reattach the velocity, reassign it at a point just after they stop their overall momentum. If you don't do that stop, then you're running the risk of sending the player off, careening off the object that they're tethering to. And there's, of course, a number of other things you could do, like instead of overriding Z, you could do a formula to be able to calculate what Z should be in regards to the player's velocity. So there's a little drop to their tether. A number of things to implement this, but this gives you the gist of how tethering can work inside of Unreal. Hopefully lets you go out there and keep building.